Okay, I'm going to go over 11.3 worksheet just to make sure that you guys are understanding some of this since you won't be here. First off, remember Boyle's law is they are inversely proportionate, so as the pressure increases, the volume will decrease, and vice versa. So they're just opposite of each other. So number one says, why does a sealed bag of chips expand when you take it to a higher altitude? Well, the higher the altitude, we learned in section 1 and 2 that you have a lower pressure. So low pressure is going to give you a larger volume. All right, so number 2, let me see if I can pull this up here. So number 2, it says the air in a cylinder with a piston has a volume of 220 milliliters and a pressure of 650 millimeters of mercury. If a change results in the higher pressure inside the cylinder, so I kind of talked with you guys that were in class about this. So if the pressure is higher, then my volume is going to be lower. So if this is what I have and my volume is now lower, it's going to be like A. Now B is a math problem, and what they give us is they give me, I know that my V1 is 220 milliliters, so I'm going to put that here. So V1 equals 220 milliliters. My P1 is 650 millimeters of mercury. So P1 equals 650 millimeters of mercury. And then down here on B, it gives me a new pressure. My P2 is 1.2 atm. So we got P2 equals 1.2 atm, and I'm looking for my new volume. I don't know what that is. All right, so I'm going to do this V1 times P1 equals V2 times P2. So here's the thing, is that in the notes, everything worked out perfectly, but I have two different pressures. I have millimeters of mercury and I have ATM. Now, I normally like to change my millimeters of mercury to ATM, but it doesn't matter what you do. You could change this one. So let's see if I can write with this pen. My mouse is really, really jerky right now, so we're going to see how this goes. So what I'm going to do is I'm going to take the 650 millimeters of mercury. I'm going to do my parentheses. Said this pen is not working real well. So remember, this is millimeters of mercury. So down here is going to be millimeters of mercury, and I know that there are 760 millimeters of mercury. Millimeters of mercury in one, oh gosh, ATM. That's a 1 ATM. Oh my goodness, guys. I'm going to have to figure out some other way around this. All right, so I'm going to take 650 divided by 760, and I'm just going to type this part, equals, and that is 900, or no, sorry. Let me get my calculator out. I did the opposite on my paper, so I've got, I turned my ATM into millimeters of mercury on my paper. So 760 is 0.855 ATM. All right, so now this is my new P1. So I'm going to just X through this. I don't know if I can do that anywhere here. I don't know. I'm just going to slash, this is 0.855 ATM. And this is what we're going to use, is right here, the 0.855. All right, so when I do this, my V1 is 220. I'm going to multiply that by 0.855, because I need these to be the same, equals 1.2 times V2. So I'm going to divide each side by 1.2. So when you take 220 times 0.855 and you're dividing by 1.2 on each side, I'm going to do an underline so you can see here. let's move this over. Okay, so I'm going to divide by 1.2 on each side, which causes this to cancel out, leaving you with V2. And your answer is going to be, I have no idea what just happened. Did everything just go away? Oh, there it is. All right, equals 156.8, and this would be milliliters. Right, once again, we can check our work. We can see that our pressure increased, so my volume is going to decrease. Okay, let's go back to the worksheet. Okay, on number 3, they just want to know, this is your balloon. What's it going to look like after this happens? So here's my initial balloon. A says the balloon floats to a higher altitude where the outside pressure is lower. Well, if pressure is lower, volume is bigger. So it's going to look like C. B, the balloon is taken inside the house, but the atmospheric pressure remains the same, so everything remains the same, so my balloon is going to be B. And then C, the balloon is put in a hyperbaric chamber in which the pressure is increased. If pressure increases, volume decreases, so it's going to look like A. Number 4 is the same thing. You're going to just look, you're trying to tell me, is this going to increase or decrease? So if you look at A, my volume has decreased, so all you need to say is pressure increased. B, volume increased, so all you need to say is pressure is going to decrease. Now on C, my volume has decreased, so you're going to say pressure increased. On number 5, you are taking your volume, your initial volume times your initial pressure, and you're going to divide it by this new volume to get your new pressure. So it should be 4.5 times 760 divided by 2. So it is just like this. Right here, you're plugging in the new numbers for it. All right, now on number 6, you are doing the same thing. You have your initial volume and your initial pressure, and they're giving you a new pressure, so they want to know what the new volume is. So here, millimeters of mercury and millimeters of mercury are the same thing, the same unit, so all we really need to do is we just need to take 50 times 760 and divide by 1500. All right, you're just taking these 3 numbers and you're plugging it into this equation right here. Your answer for A should be 25.3. For B, here's the problem. You have millimeters of mercury and ATM, so they're different. So my first step is changing one of these. It doesn't matter. Now what I did is I changed my ATM right here. So instead of 2 ATM, you're going to have 1,520 millimeters of mercury. It's a one-step conversion problem. You're going to put your parentheses right here, and you're going to have 1 ATM on bottom, and you're going to have 760 millimeters of mercury on top. That is how I'm getting my 1,520. Once I have that number, then I can plug all 3 numbers into that equation, and your answer should be 25. All right, so if you have any other questions after this video, please let me know. Thanks. Bye.